Okay, so today we will try to together design a kind of a blockchain system design. And many of you heard about the Web3 architecture, but maybe you will not know clearly how we can design and we can build a kind of a Web3 applications. So let's together today we will build a Web3 system application together in the system design level. Before going to type Web3, maybe we need to mention a little bit and discuss about, I would say, for for Web2 application. For example, in you have the Facebook website, and maybe it's so simple. Um, in the Web3 architecture design, normally we will have kind of we have say uh, we have the user first. Let's design the users, and we have the user here. Uh, yeah, you have multiple user, and in Web2 application, it will communicate with a web server. Yeah, that is here. We have the web server here, and in the web server, it normally will include two parts. The first one is we say front end, back end first. Let's say that the back end. The back end here is normally is kind of the logic behind. I would say the logic of the application right? Okay. And to communicate with the back end, we need kind of we call the front end to show and present the application as well. So the user can interact with the front end application via, for example, we say we web browser like the Chrome or Firefox or things like that. So here we will have the uh, web browser here. So it means that when you try to log in on the Facebook, right? So you are user here, so maybe you will interact uh, with via the web browser, and the web browser here will interact with the front end. The front end here you can write, for example, in JavaScript or HTML, CSS, and JavaScript. And then after that, the front end will interact with the back end code. For example, for the backend, you can write it in, for example, Python or Golang, and so on. In the Web2, like I said, for example, when you design, like I said, you need to a place to store the data, and it's where we have mentioned about the database player role here. You have the database yeah, database will be here, so the data will be recorded from the backend to the database. Yeah, and database. Yeah. Okay, so this is the simple architecture of the web 2 applications. Yeah. In the blockchain and Web3, we have a little bit different. I will still keep everything in the Web2 here, so you can keep it. Okay, I will make the Web2. This is the Web2 architectures. Yeah. Right. Okay. So now we want to discuss about Web3. Okay, I will put here for Web3. Actually, compared to the Web2 and Web3, I think there are some parts still the same, but there's some component, for example, backend will be different because now the the core the core concept of the Web3 will be the blockchain application. So compared to that, it will a little bit different. As you know, that the blockchain is kind of the decentralized ledger where we can store the data on chain, and the data will be in transparency, immutability, and will stay in that forever in the blockchain in the application. So the Web3 normally now we have many platform in many blockchain platform, for example, Ethereum, Polygon, or Binance and Solana as well. So, but the most popular platform would be the Ethereum and EVM-based blockchains. So to design a kind of the Web3 application, everything is quite the same. For example, you still, I would say, you are still have the user here. Okay, we are still user here, and you still need a web browser to interact with the application as well. Um, okay, and this is the web browser, right? You still have the uh, you still have the web browser. You still have the web server. For example, in you still have the front end to interact with via web server here, and yeah, this is the first thing. I think we send it to the back. Okay, so the difference here is that instead of you have the backend service here, now you will have the blockchain service, the blockchain network, and I would say here we have the blockchain here. You will have a blockchain node here, the blockchain here. Okay. Okay, I would say that is I would take it as a blockchain node here. Uh, the blockchain network here. Okay, and here you have a blockchain. Uh, Here is the blockchain network. I would say it's a digital ledger as a blockchain for the recorded data of the blockchain, right? Okay. But compared to the Web2 application where you have the backend logic, so now in the Web3, the logic will be and the application will be defined in the concept of the smart contract, uh, the contract. Uh, Second, yeah. Yeah, we will have the concept of the smart contract here. It is will be the smart contract. The smart contract is kind of the programmable logic and can be written in, for example, in Ethereum we use the Solidity. In Hyperledger Fabric we use the chain code using the Golang, and it is kind of the logic behind any applications you write in the Web3. So, for example, you can have a multiple application and multiple types of applications you can define. For example, in the Web2 applications, you have the backend logic you can write in the Python, Golang, etc., and so on. And here you can define the application in the smart contract like this, and the smart contract will be running in the blockchain network. And for example, in the system, you have the multiple blockchain nodes, so smart contract will be implemented in that node and communicate. You can interact with the smart contract and the logic via the front end. This is, for example, I would say this is one kind of example of the Ethereum network here. Yeah, things like that. So you can have this one. Da, 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 da. Okay. you can have this one as the blockchain network here, and the front end will be interact with the blockchain network to um, this is the kind of the simple Web3 application for you to interact with the smart contract and the blockchain. So let's go deeply a little bit more detail on the system. So how the difference between the Web2 and Web3 is that now you it's not easy and not simple like the front end will interact directly with the smart contract of the blockchain network. There are two ways you can, because we want our front end to communicate with our smart contract, so the user and the front end can invoke the functions, but because the Ethereum is kind of decentralized network, so in Ethereum every node will keep a copy version of the blockchain, and including the code, the application, and the data associated with every smart contract. So when we want to interact with the data and the code on the blockchain, we need to interact with one of these nodes. So this is because any node can broadcast a request for a transaction to be executed on the EVM blockchain. So a miner will then execute the transaction um, and propagate the result state to the whole node. And actually, there's two way. This I would say that this is a blockchain. There are two ways you can interact or build or broadcast a new transaction. The first one is that you can set up your own node, your own blockchain network. For example, you can you have the server and you can download the Ethereum from or internet node. For example, you can using the get library client for set up the own Ethereum network. Or the another option is that you can use kind of the third party service provide for example, you can use uh, the third party service to interact for kind of the Web3 provider. We call it a Web3 provider here. For example, you can have the Infura or QuickNote or maybe Alchemy. This is quite popular, or maybe the MetaMask as well. This is the way you can interact between this, and you can communicate with the Web3 provider via the I would say via we can via the JSON RPC. Yeah, it is a way. And from that Web3 provider, you can interact with the blockchain network like that one. Yeah, okay. So, yeah, this is one of the ways you can interact and set up the system like that one. But however, for example, when the end user want to public any data to the blockchain network, so it means that each user will have the key pair to identity them who they are in the internet, or maybe you need a private key to sign the transaction and sign the data. So we need a kind of the signer here as well for we use the MetaMask. You can set up the MetaMask on the web browser as well. MetaMask here, okay. I find the icon for the MetaMask, so you can find it on the internet. You need a signer for that. Okay, here we go. The signer is group. It is kind of the extension of Chrome, or maybe of the web browser. So when you want to public any data to the blockchain, the first one is that you need to install the the MetaMask, and then the web browser will sign using the MetaMask to sign the transaction of the data, and then it will the data will go through here to the front end here, and then the data will interact via some RPC and or maybe Web3 to interact with the blockchain node and publish the data to the blockchain. So yeah, that is you can see the difference between the Web 2 and Web 3 here start. We have still have the user the same. We have the web browser here, and the difference is that we don't have kind of the backend server in the Web 3 architecture. The backend server now will be replaced by the blockchain, by the digital ledger, and the smart contract for the backend, for kind of the application, the logic application. So what is missing here is that we don't have the database right here, right? Actually, in the blockchain, for example, in EVM by blockchain like Ethereum, the storage in the blockchain is very expensive because you need to pay the gas and fee for any kind of operation, any transaction in the system. So it's not a smart way to record everything to the blockchain. So how about the database in the Web3? Normally we will use a kind of the digital storage. Would say it is maybe we can use the IPFS or Swarm. Um, IPFS and Swarm work like this in this way. For example, when you want to publish data or want to do any operation on the blockchain, the data will be recorded to the distributed storage. It's kind of the off-chain storage, and then only hash version of the data from the off-chain storage will be recorded to the blockchain network. Only hash version of this one. For example, would say here we have the hash of the data will be recorded to the blockchain, so you can reduce a lot of data storage on the blockchain, a lot of say a lot of gas or fee on the cost for storing blockchain. For example, you cannot store kind of the video or movie to the blockchain. Maybe you record the data and you store the data or movie on the digital storage, and a hash version of that data will be recorded to the blockchain. Yeah, this is a way for doing that. Yeah, okay. So okay, so now you have the actually the storage of blockchain here, the data between the um even if for the data in the front end, you also can record to the blockchain node here. So to say the fee as well. It can have a lot for interaction. Okay. Like this one, the data from the front end normally we're in the web 2. Maybe sometimes you need to record and store the data on from the front end in the database, right? So in the web 3, you also can do the same thing. You can record the data from the front end to the object storage like this one. So other people can easily to query the data from that. So how to query the data? For example, in this one now we don't have the web server here. Maybe we can have the IPFS or maybe Swarm here for recording the data for the front end. And to query the data from the front end, maybe we can use a kind of uh, you can use the graph technology to query. Yeah. Um, Actually, this is just one option. You don't have to know about the graph, or maybe you just can use the API, for example, the APIs or things like that, or to query the data via the API interface, right? But when you want to query, maybe reduce about the number of queries from the system and reduce the communication overhead. So maybe you can use a graph. With just one query, you can get everything from the blockchain network, and the graph is quite simple, quite popular now for that one. But that is okay. Until this step, you can have a full version of the Web3 architectures. It could include, for example, user web browser interface, web browser here, and you need to have a signer, a MetaMask to sign your smart contract, and to sign the data as well. And this is the MetaMask will can be installed on any web browser. For example, Chrome, Firefox, I am Internet Explorer as well. So from the front end, you interact with the blockchain via some Web3 provider like Infra, QuickNote, Anchimi, or MetaMask. In case you don't want to install or set up your own node, blockchain node in your machine, so you can use a Web3 provider to interact with the blockchain. And about the storage, you can store the data off chain in IPFS or Swarm and IPFS Swarm will, for example, when you want to record the movie, right? And uh, when you want to have the big, for example, you have a lot of data to want to, I would say, for example, document. Yeah. For example, when you have the data you want to store on the blockchain, so you will store that data in the IPFS, and that IPFS will return to you a kind of the CID of the data. Uh, it's kind of the hash version of the data, and then next time once you want to get us, then you just need to query via the CID that, and then the IPFS will return for you the content. So it means you don't need to have to store everything on the blockchain and EVM. That's a very important problem. This is kind of we consider like the scalability issues of the blockchain network, because blockchain normally we can say the process quite slow. So if you record a large volume of data, it will reduce the efficiencies and availability of the blockchain system. So it's better to record the data off chain. And actually, there's quite now recently we can have multiple solutions for scaling. So how to scaling the app? Maybe you can think about using the off-chain storage like the IPFS one, or maybe you can think about a layer two scaling solution. For example, I would say we have uh, okay, here I will copy this one to here to make a better view. Okay, how to scaling the application. In order to scaling the application, now recently we have the a solution we call it the layer two. Layer two mean that layer two application, right? So layer two solution. The layer two means that now you will not record data on chain on the Ethereum, for example, into Ethereum work. It's now record in the off chain. It means it can be considered like the side chain or in outside of the blockchain to reduce the overhead and just try to scaling the application. There are multiple solutions for off-chain. Maybe you can think about, for example, we can use a recade rollup, or maybe it can be kind of the can be optimistic rollup as well. And I mean, there's quite a lot of the solution for this one, and it can be okay. It can interact via the with the front end, and this one will go through the to interact with the blockchain. It will reduce this one, and there's quite a lot of the solution for the layer two. For example, you can have in the Polygon network. This one, or maybe in the Ethereum, for example, for layer two solution. Okay. Okay, one second. Actually, there's quite a lot of those solution for layer two. You can think about, for example, using the Polygon or maybe using the Arbitrum, or maybe yeah, things like that. There's quite a lot, and this is the way you can optimize the solution for try to scaling the solution. Maybe you can think about using the layer two, apply layer two approach as well. Yeah, so that is the way you can design a blockchain and Web3 application for the project. And actually, I understand that it's not easy to understand from the beginning, but when you try to write down a little bit more, maybe it will make more sense for that one. Okay, so just feel free to comment if you have any question on the designing Web3 architecture, and very open to discuss on that one. Thank you.